The Duke Superfund Community Engagement Corps held its annual Community Advisory Board meeting virtually on July 17, 2020. We were fortunate to have presentations from 2 Superfund trainees and 1 investigator from the Nicholas School of the Environment to share their work with our board. The researchers also participated in discussions on topics related to our Community Engagement Corps throughout the day.
I am really excited today to talk about some research that we've been doing looking at children's exposures to chemicals in the home environment. So people spend a lot of time indoors. In fact, we spend most of our time indoors, and particularly right now, we're all spending a whole lot of time at home. So that's interesting in terms of chemical exposures because the building materials and consumer products in our homes, so things like furniture and electronics, are very often treated with different chemicals to meet construction codes or safety ratings for those products to be used in our homes. So an example of something like this might be like a flame retardant chemical that is added to meet regulations for furniture production. So things like the polyurethane foam used to make furniture in your home is often treated with a flame retardant chemical. So I've listed a bunch of chemicals here under this sort of house diagram. I don't think we need to go into the specifics, but I'll just say that we're really interested in things like flame retardants in the home, different plasticizers, different fabric treatments, things that are making furniture and products in our home stain resistant and soil resistant, as well as pesticides. So it's a really big class of compounds. They're used very frequently, and as a result of that, they're detected in most indoor environments. And the reason for that is because just because something is added to your couch as a flame retardant doesn't mean it stays there. So over time, all of these chemicals work their way out into your home indoor environment, leading to potential exposure of people living in the home. Sort of the primary routes of exposure that we're interested in are either through inhalation or breathing in chemicals that can be in the air. Either they've sort of volatilized off a particular product, or they're sort of attached to small dust particles that you're breathing in. We're also really interested in absorption through the skin, as many of these compounds can be absorbed dermally. And then also this idea of the inadvertent ingestion of dust in the home. So you can kind of imagine as you move around your house and touch different surfaces, you end up with sort of a really fine layer of dust on your hands. And then as you kind of touch your face or touch your mouth, you kind of ingest a little bit of that dust each time you do that. So we do eat the dust in our homes. Okay, so we're particularly interested in children's exposures to chemicals in the home, and the reason for that is sort of twofold. First, we know that children are more sensitive to environmental exposures than adults. As they're developing new systems, there's the potential for greater adverse impacts. And then we also know that children's exposures aren't the same as adults' exposures. And in fact, we think children are sort of more highly exposed to the contaminants in the home. And the reason for that is that children are not simply little adults. They actually breathe more, eat more, drink more per unit of body than adults do. And their behavior is also different that can lead to higher levels of exposure. So children are really frequently putting objects or their hands in their mouth, which leads to higher ingestion of dust in the home, which can have chemicals in it. And then kids kind of interact with the environment differently. So one thing for me personally, because I have 2 small kids, I feel like they have really changed my home environment in that we're suddenly bringing in way more products and a lot of them are plastic. So we have way more plastics in our house than we did previously. And then the way that my kids interact with their environment is different than the way I do it. I don't spend a whole lot of time laying on the floor, but they spend quite a bit of time down there playing around. And so all of those things can lead to higher intake of dust, which is potentially a very important pathway of exposure for a lot of compounds in the home, and particularly for children, since they do get more dust in than adults do. And so we've been really interested in identifying what factors contribute to children's exposures in the home. And to do that, Heather Stapleton here at Duke started the Toddlers Exposure to Semi-Volatile Organic Compounds in Indoor Environment Study, or TESSE study, in 2014. And for this study, we contacted women who had participated in a pregnancy study here at Duke when their kids were between 3 and 6 years age, and asked if we could come in and sort of look at, well, what is your child exposed to in your home environment, and sort of what behaviors or what factors about your home contribute to higher levels of exposure. So we recruited 203 children, and then we went out and visited them in 190 different homes here in the Triangle. Since it was originally a pregnancy study and everybody had to have their baby at Duke, most of the people in this study are from Durham, though there's some from sort of other kind of surrounding areas, all within driving distance because we did conduct a home visit. And there are a few siblings in here in the study as well. So as sort of an environmental measure of what's in your environment, we collected house dust samples. There's a picture of Stephanie Hamill doing that in a home here at the bottom. We collected them with a vacuum cleaner, and this was really meant as a proxy for what the exposure in the home would be like. And each of those dust samples, we measured a bunch of different chemicals, those ones that were listed on the slide I showed previously, but they included things like flame retardant chemicals, plasticizers, and pesticides. So it was a really broad range of compounds. And then we also wanted to know not just what's in the environment, but what's actually getting into kids' bodies, right? That's where it has its potential for a health impact. So to do that, we collected blood and urine samples, and in those we measured biomarkers of exposure, which are sort of like tracers of exposure to those compounds. So in blood samples, we might measure the compound itself in a blood sample, or in a urine sample, we might be able to say, well, you took in this compound and we know that that compound is metabolized in your body to a certain compound. And so is that excreted compound in your urine? So we collected both of those samples from as many children as we could. Not all the kids wanted to do a blood sample, as you might imagine. So I won't go into too much detail about the specifics for any one compound, but I'll just say that a number of the compounds that we evaluated were detected really frequently. So 70% of the biomarkers that we evaluated were detected in at least 90% of children in the TESI study. So certainly a lot of chemicals. This figure here shows some specific individual compounds and that were measured in urine and some that were measured in blood. And it compares our study, which is the TESI study, to the National Health and Nutrition Examination Survey, which is sort of a nationally representative study of the US population. So we looked at comparing kids in the triangle to kids in that study. And what you can see from this is that we do have higher levels of some of these biomarkers for parabens and also for phthalates or plasticizers in this particular cohort of children. So that's very interesting to us. These were both kind of similarly aged children and samples collected about the same period of time. So in that sort of 2014 time range. So that's certainly something that we were really interested in, what might be leading to differences in exposure. And one sort of particularly interesting point to us was, well, what are the characteristics of the homes that these children are living in and how might that be contributing to exposure? So I'll just acknowledge Stephanie Hamill and Jess, who both led this project looking at phthalates in the home environment. So phthalates are really frequently used as plasticizers and in personal care products. They're also potentially used in the vinyl flooring like I've shown here, like many of us have in our homes. Vinyl is really commonly made with phthalate plasticizers, and we suspect that a particular phthalate known as benzyl butyl phthalate is frequently used in producing these flooring materials. So we were interested in this idea of, is the dust in homes that contain vinyl flooring, does it have higher levels of benzyl butyl phthalate because this material is used in the home? So in each home, we characterized the type of flooring, whether or not it was vinyl, wood, and then we divided each home up into sort of groups of folks that had 0% vinyl or folks that were all the way up to 100% of the flooring in their home was vinyl. And then this figure shows the amount of benzyl butyl phthalate in dust for each category of increasing vinyl flooring in the home. And what you can see here is kids who, or for homes that were 100% vinyl flooring, they had benzyl butyl phthalate levels that were 4 times higher than dust samples collected in homes that had no vinyl flooring. So certainly it looks like the more vinyl flooring in the home, the more, the higher the levels of this particular compound in dust, which you might expect just given that that material is potentially made with this compound. And so for us, a really important question was, okay, so that's, you know, do kids then have higher levels of exposure? And so we looked at that, and that's kind of what's shown here in this figure. You can see that kids who were living in homes with 100% vinyl flooring had a biomarker of exposure for benzyl butyl phthalate that was 15 times higher than kids living in homes with no vinyl flooring. So it certainly seems in this case, living in a home with this type of flooring is related to higher levels of exposure to this compound. We wanted to look at that a little more broadly and also evaluate racial and ethnic potential differences in exposure. And I won't go into a ton of detail here, just to say that these figures show the results for non-Hispanic Black participants and Hispanic participants and their relative to non-Hispanic white participants of the study. So if a particular compound is shown here on the right-hand side or greater than 1, that means that that particular group had higher exposure on average than non-Hispanic white participants. So here you can see, particularly like for example, for 2,5-dichlorophenol, you can see that non-Hispanic Black children had levels of that compound that were 4 times higher than non-Hispanic white children. We saw a similar increase in Hispanic children as well. It's sort of an opposite pattern for this compound, benzophenone or BP3. This is a compound known to be used in sunscreen, and we think that this may reflect differences in the usage of sunscreen in non-Hispanic white, non-Hispanic Black, and Hispanic participants in this study. So just sort of as a main takeaway from this slide, what I would say is that we noticed that these groups tended to have higher exposure to a number of compounds than non-Hispanic whites, particularly parabens and phthalates, which are frequently used as plasticizers and in personal care products. So we were interested in looking at sort of that relationship in more detail. So this figure actually displays the results for each individual participant across the top. So each column is a participant and each row is a particular chemical. And here, if something is shaded blue, it means that that person had an exposure to that chemical that was lower on average than the population. So you can kind of see, we've also sorted them in terms of, on the left-hand side, blue is lower average exposure, and pink on the right-hand side is higher average exposure to everything. Oops. And an important thing to point out here is one, that no one is really highly exposed to everything and no one has low exposure to everything, but we're all sort of exposed to this mixture of compounds. And as I said, we're really interested in these potential environmental justice issues in terms of indoor exposures. And so I've just highlighted here in gray which of these children were racial and ethnic minorities. And you can see here that those who were non-Hispanic, Black, and Hispanic tended to have higher levels of exposure on average to everything, not just any one specific chemical at a time. So as the main takeaway points, children are really commonly exposed to chemicals in the home environment, and those exposures occur in mixtures. There appears to be an apparent racial, ethnic, and income-based disparity in exposure here in the triangle. I didn't talk about the income results, but they are very similar. Products in our home may be a source of exposure, a chronic exposure over time, and certainly more research is needed to understand the health impacts of exposure to chemical mixtures, particularly for young children who may have higher levels of exposure. So I'll just really briefly acknowledge the folks who participated in or helped with this work, including the participants in the TUSSE study, and Dr. Heather Stapleton, who is the principal investigator of TUSSE and whose lab all of the analyses that I showed for today were conducted in. So with that, I'll just take any questions if there is time.